We have a parabola with the equation y equal to x square plus px minus 3, and this passes through x and y axis at 3 points p, q, r. A circle with center minus 1, minus 1 also passes through these 3 points. We need to find the area of triangle PQR. So before diving into the solution, let's visualize this question on a Cartesian plane. So we have a Cartesian plane, x-axis and y-axis. So x-axis equation is y equal to 0 and y-axis equation is x equal to 0. So on substituting these values, if x is equal to 0, so we have the equation as this way. So if x is equal to 0, y equal to minus 3. So one of the points is derived now. So it is 0, minus 3. And if y equal to 0, this implies that x square plus px minus 3 equal to 0. This is a quadratic equation, and if in a quadratic equation we know that if alpha and beta are the roots of this equation, then alpha into beta equal to this value, that is alpha beta equal to minus 3. Since this is a negative value, it means that one of them is a positive value and the other is a negative value. So they lie on either side of the y-axis. So let's put them on the Cartesian plane. So one of them will be alpha, 0 and the other is beta, 0. And the third point is 0, minus 3. Right? So this is basically a upward facing parabola, we can say. So let's assume the parabola goes this way. Right? And also we know that a circle with center minus 1, minus 1 passes through these 3 points. That means that suppose here it is the center of the circle, say. Now this is it. The circle passes through all these 3 points, right? And it is equidistant from all these 3 points by radius r actually. So the locus of the circle would be x minus of minus 1 whole square plus y minus of minus 1 whole square equal to r square. So x plus 1 whole square plus y plus 1 whole square equal to r square. So this is the locus of the circle. Since 0, minus 3 also passes through this circle, so we can substitute those values and eventually 0 plus 1 whole square plus minus 3 plus 1 whole square equal to r square. This will lead to r square equal to 5. So we can put this value back here and we will get the equation as this way. Now if we substitute y equal to 0, we will get the x intersection points of the circle. That is the same intersection of the parabola points. So plus 1 equal to 5. That is x plus 1 equal to plus or minus 2 it is. So this implies that x could be either minus 3 or 1. So these points are 1, 0 and minus 3, 0. So we know that if x1, y1, x2, y2, x3, y3 are 3 points of a triangle, vertices of a triangle, then area of triangle will be half of det of x1, y1, 1, x2, y2, 1 and x3, y3, 1. So eventually we can substitute all the 3 points which we derived here, 0, minus 3, 1 and 1, 0, 1 and minus 3, 0, minus 3, 0, 1. That is eventually the answer would be 6.